A factory produces two kinds of machine x and y. The cost function is given as cxy equals to x squared plus 2y squared minus xy. If the factory has fixed the production output to 8 units, how many of each machine should be produced to minimize the cost? So for this question, our function c, which is the cost function, equals to x squared plus 2y squared minus xy is subject to the constraint which is, so from the sentence, if the factory has fixed the production output to 8 units. Okay, so our constraint is x plus y equals to 8. Means we're going to use Lagrange multiplier method to solve the problems. So you may write down the constraint as gxy equals to x plus y minus 8. Let's form a new function c x y lambda equals to cxy plus lambda gxy. So the function c is x squared plus 2y squared minus xy plus lambda. The function g is x plus y minus 8. If we expand, x squared plus 2y squared minus xy plus lambda x plus lambda y minus 8 lambda. So now let us find c sub x. So let us differentiate with respect to x is x squared with respect to x is 2x. Differentiate 2y squared with respect to x is 0. Differentiate negative xy with respect to x is negative y. Differentiate lambda x with respect to x is lambda. Differentiate lambda y minus 8 lambda with respect to x is 0. So c sub y. Differentiate x squared with respect to y is 0. Differentiate 2y squared with respect to y is 4y. Differentiate negative xy with respect to y is negative x. Differentiate lambda x with respect to y is 0. Differentiate lambda y with respect to y is lambda. Differentiate negative 8 lambda with respect to y is 0. Now c lambda. So we can differentiate this one with respect to lambda. If we see the terms x squared plus 2y squared minus xy, there is no lambda, so they become 0. So if we differentiate lambda x plus y minus 8 with respect to lambda, so we're going to get x plus y minus 8. Or we may simply just copy down the x plus y minus 8. X plus y minus 8. Okay, so the second one, okay, what we have to do is we're going to equal our equation with 0. So we have 3 equations here. So 2x minus y plus lambda equals to 0. We have 4y. Let us rearrange according to the variables. So I'm going to write down negative x in the front. So negative x here. Negative x. 4y behind. So plus 4y. plus lambda equals to 0. So that will be easier when we minus these two equations, right? Okay, so if we minus 2x minus negative x, we're going to get 3x. Negative y minus 4y is negative 5y. So lambda minus lambda is 0. And equals to 0 minus 0 is of course 0. So it is easier if we get rid of the lambda first, right? Okay, so the next step is we have the third equation, which is x plus y minus 8. So I can write down my x plus y minus 8 equals to 0, and y equals to 8 minus x, right? Okay, so what I'm going to do next is I'm going to substitute. Let's say this is the first equation, this is the second equation. I'm going to substitute my second equation into the first equation to find the value of x, right? Okay, so 3x minus 5 times 8 minus x equals to 0. If we simplify this, we're going to get let us expand first, right? 3x minus 40 plus 5x equals to 0. So I'm going to get 8x here, right? If I bring my negative 40 to the right hand side, I'm going to get positive 40. So 40 divided by 8 is 5. So x equals to 5. So next is I'm going to substitute my x equals to 5 into the second equation to find the value of y. Okay, so if you substitute y equals to 8 minus 5 is of course 3. Okay, and don't forget to find the value for lambda. Okay, we have another equation which is negative x plus 4y plus lambda, so we can find the value of lambda there. Okay, so let us substitute the value of x equals to 5 and y equals to 3 into the third equation. Okay, we have negative x plus 4y plus lambda equals to 0. So negative 3 plus 4 times negative 5 actually plus 4 times 3 plus lambda equals to 0, and my lambda will become negative 7, right? Right, yes. Okay, so what's next is what we understand from here is we have a minimum point. Okay, so how do we know it is a minimum point? Is from the word minimize cost. Minimize cost. Okay, so we have a minimum point. Okay, so we may write down as minimum, so I write down here, I think minimum points is 5, 3, negative 7. So what can we derive from here? Means that we have 5 units of machine X and 3 units of machine y to minimize the cost. So that is how we use the Lagrange multiplier method to solve the problems. So that's it.